Hello everybody, my name is Jim Pingle and welcome to our September 2016 Hangout. This month we'll be talking about the DHCP server on pfSense. So a little bit about this Hangout. First up we'll have project news. And due to the length of what I've got to go over here, there's a lot to cover, so I'm only going to do IPv4 right now. I did cover IPv6 during the IPv6 Hangout a few months back. So if you're interested in that, you may have to go back, or I may have to do another one of these that's just for IPv6. But there's a lot more here than I initially anticipated, so we're just going to do IPv4. We're going to talk about what DHCP is, whether or not you even want to use the DHCP server on pfSense. We'll talk about what DHCP pools are, the default behavior of DHCP on pfSense, how the DHCP server decides to assign addresses. And then we'll go over in detail all the options on the DHCP server configuration. We'll talk about working with multiple address pools. So we'll talk about static mappings, looking over the leases, like status and lease, the DHCP lease status. We'll look at the pool usage graph. That's a fairly recent new item. Okay, first we got some project news. We are going to have a 2.3.2_1 or patch level 1 security release. We're testing it right now. We were hoping to have it out this week, but we've ran into a couple things we're testing. We're having to rebuild it and retest it. So look for that early next week. It will have OpenSSL patches in it for recent issues that were uncovered. Nothing major, some OCSP issues for HA proxy and for free radius, I think it was. Not much else of great impact. There's a minor memory leak, but eventually gets freed. So there's some denial of service potential there, but nothing huge or major. It's definitely nothing, on the scale of like Heartbleed or something. So it's important to get the fixes. We'll have them next week, but it's not, critical like rush it, get it out right now at this moment. There are also some package updates for things like PHP, libxml, and a few other things that had their own vulnerabilities. And then some miscellaneous other bugs, things in the GUI that we've got patched up. Like I said, that'll be out. We're hoping sometime early next week if our testing proves good over the weekend, early next week. We also do have 2.4 alpha snapshots available, and they are definitely alpha quality. Do not run them in production, but they are good for lab testing and checking things out. They're based on FreeBSD 11, so we've got things like a ZFS in the installer and newer base OS and a newer driver set and a lot of other things there. Some things are still missing. Some features, like I think Captive Portal still isn't quite working. Wireless isn't quite working, and there's some issues with routing. But we are actively working on it, but definitely not production ready. But if you want to try it out in a lab or on a test system, the basics are there if you want to play around. We do also have 2.3.3 snapshots available. If you want to check that out, they're much more conservative than 2.4. They're basically just not a little bit further ahead than the 2.3.2_1 stuff. And those are all available at snapshots.pfsense.org. If you want to visit that site, you can download update images there. I don't think we have a way to update via package right now, but you can reinstall from a fresh image and restore a config pretty quickly. Again, not something you'd want to try necessarily in a production, but for a test system, sure. And you can go in a current install and in your update settings, you can set that to go to the development train. That should get you 2.3.3 for those. It's just for a manual update, you have to go through the GUI or the option 13 from the console or pfSense upgrade from the shell after you've set that option. The micro firewall that I talked about last month, our new little 2-port ARM box, it is now called the SG1000. We do have them available for pre-order from store.pfsense.org. If you go there, we're going to ship those out in a few months once we have everything in place for the 2.4 release, because the 2.4 release is where we're picking up the ARM support for it. We've got some pretty promising numbers. Just this morning, we put out some numbers on a Reddit post from Jim Thompson. He was doing some speed testing on it, or he was reporting on the speed testing we've been doing on it. And numbers were pretty good. Like even with PF enabled, like packet gen was getting us it was over 300 megabits per second on a tiny little ARM box, which is pretty impressive. And without packet filtering at all, it was doing 500, I think it was. So it's getting some very good performance out of it, and we're hoping we can even squeeze a bit more out of it from there. But those are like best case testing scenarios. So we'll see how that goes. But they're looking to be very, very nice little boxes. We also had an article written that included a lot of pfSense by PC Gamer this month. So if you haven't seen that yet, go ahead. You can follow that link from the Hangout notes later, or go to pcgamer.com and you can look that story up, or just type in pfSense. You should be able to find us there. But he talked about getting a very fast fiber installation in his house. I think it was like 10 gig fiber or something like that, and then or it was that he needed 10 gig fiber. It was really just like I think it was like a 2 or 3 gig service, but it's pretty fast stuff. And he was pushing the pfSense box he had pretty nicely. So he has some good things to say about us. So go ahead and check that out. We are also on the support front. We're going to be doing 24/7 enterprise support pretty soon. So keep an eye out for that. We'll have that coming up shortly. All right, moving on into the content here. First up, what is DHCP? A lot of people take it for granted. They may not really realize what all's going on there. DHCP stands for Dynamic Host Configuration Protocol, and it assigns client addresses automatically. So the client will send out a request. It doesn't have an address yet, sends out a little broadcast message to the entire segment there that says, hey, I'm looking for an address. And then the server will pick that up, and it will respond back with an offer for an address. And then the two of them will work out a little bit of an exchange. The exact procedure depends on several different factors. But the nuts and bolts of it are, the server will respond, the client will go call back to the server, and they'll make an exchange, and they'll decide on what address the client can have. It's very convenient. It's much easier than going around to all your computers and setting IP addresses manually. If you've been in the business a long time, you might remember a time before DHCP was really trusted or very common, when you were forced to hard code everything by hand, and all of the pain that entailed there. So you don't have to worry about hard coding everybody, or keeping track of everybody's IP addresses individually and like an IPAM or a spreadsheet or a text file or anything like that. So it just handles all of it for you automatically. Running a DHCP server is a common default on many firewall and gateway devices, so like pfSense or any like Netgear or ASUS OpenWRT, whatever box unit. It's generally going to be running DHCP on its LAN side. What you need to look out for there is things that you might run into a case where you've got two of them hooked up to the same LAN. You could have conflicting DHCP servers, so that's something to watch out for. But I'm not really going to talk about that a lot, but it's just something to be on the lookout for. It is a common default, so you might have to disable it on everything but one device on your network, because you don't really want multiple running like that. So the server itself maintains a lease database, and it can also control addresses that go to clients through mechanisms like static mappings and pool access controls, which I'll talk about. So it can be like a free-for-all, or you can sort of guide it a bit more if you want to. For pfSense to act as a DHCP server, the interface on pfSense has to be configured with a static IP address, and it has to be in the subnet that contains the addresses you're going to serve. So because you have to be directly connected at layer 2 to that subnet in order to act as a DHCP server for that segment, at least on pfSense. So if you're wanting to serve up addresses, you have to be physically connected to that network so you can see those broadcasts and respond to those broadcasts. All right, well, before we talk too much about how to do it, you need to figure out if you really want to use it. So, do you want to even use the DHCP server on pfSense? Well, for most cases, yeah, it's going to be a great option because it's convenient. It's right there on the firewall. Most people don't need more than we offer in the GUI for their client options, and it's nice to have a GUI and manage it like that. And it's really simple for most people to administer. And if you got just typical clients and normal types of pools and ranges and so on, then you're going to be fine. You're not going to run into any problems using pfSense as the DHCP server. I mean, even a pretty large deployment is going to be okay as long as your hardware is capable and of handling the load, and that all the options you need are possible in the GUI. There might be, an absolutely massive DHCP server that you're going to have to run dedicated, and we do kind of advocate that. It's good to have separation of services. If you have the capacity to run a separate DHCP server, you probably should. But it's convenient to do it on the firewall, but it's not necessary if you can do it otherwise. And a very common exception to that is if you have Active Directory. So if you've got Active Directory, like it's a Windows network with Active Directory, you could use pfSense for DHCP, but you really don't want to. You want to use DHCP and DNS all out of Active Directory for its integration and service discovery, host registration, things like that. All work a lot more seamlessly if they're all tied into Active Directory. So yeah, if you really wanted to, you could use pfSense for DHCP in that scenario, but you generally want to leave that to the Active Directory structure. I've seen some corner cases that are okay, things like if your Active Directory is in a virtual machine, but your pfSense is physical, and there's a point where your Active Directory could be down, but the rest of your network isn't. Then there are some cases for it to be done from pfSense, but more often than not, you want it done from Active Directory. So another case is if you're trying to serve DHCP for not directly connected networks, say they are across a VPN or several routes away, or several hops away through a layer 3 router or layer 3 switch or something local where you're not sharing a layer 2 with them, then you can't do it. Now the daemon itself that we have is, but we don't have a GUI to represent expressing that in a way where you say, I want to serve these networks that I'm not connected to. We don't have a way to accommodate that right now. It's something we've looked at a couple of times. We've had some code submitted for it, but it's nothing that we've integrated yet. And another case where you wouldn't want to do it is if you need complicated class matching, or you need complicated group behavior, things that generally just things you can't express in our GUI that might be possible at a lower level, where you need the extra control. So you might need to set up a separate DHCP server and manage that configuration file manually. Okay. Well, say you've decided we're going to do it on pfSense. Well, first thing you need to figure out is what a pool is. So your DHCP pool is your range of addresses out of which you get your dynamic assignments. And that DHCP pool is going to be a range of addresses expressed like our usual default is 192.168.1.100 to 192.168.1.199, and that is inclusive. So a client, when it makes a request, it could get any address from 100. It could get 100. It could get 199. It could get anywhere in between, depending on what's available and what the server picks. So there could be multiple pools. And they could all be on the same interface or separate interfaces. So those are represented a little bit differently. If you have multiple pools on the same interface, they're going to be all on the same tab, the configuration. Separate interfaces are going to be on separate interface tabs. So the separate interfaces aren't generally considered, or we don't call them multiple pools as such, but technically that's what it is. You have a pool per interface, more or less, or each static interface anyway. And when you're coming up with these pools, you want to make sure they're big enough to hold all the clients you could possibly need, or you want to design them in such a way where you could extend them to carry those clients if you need them eventually. So you want to consider that in your design when you're laying out your network initially. You want to make sure you align your subnets in a way that you leave yourself room to expand. So it's kind of tempting to butt all your networks up against each other. Like you have your LAN as something .0/24 and your DMZ as .1.0/24, and something else, your voice is .2.0/24, and they're all next to each other, which logically, when you're looking at it initially, might make sense, but it really puts you in a bind if you ever need to grow any of those. So if you've got 200, 220 clients, you think you might push the limit of a /24, then you need to think about, are you going to split these up into multiple subnets? Are you going to renumber something and expand this into a /22 or even a /23? So you need to, consider all of that before you come up with this. And then you don't have to use all that space in your pool right away. You could just make a pool of a smaller size in your out of your larger subnet, and then eventually, grow it later. And so, depending on how you design that, if you design that with them all butted up against each other, it's going to be very difficult to grow. So, you want to make sure you leave yourself enough room. Spend some time with a subnet calculator when you're laying out your network, or if you're thinking about adding capacity to your network, then something you might want to consider is you might have to end up renumbering more than you might think of now to save yourself some trouble in the future. Okay, so out of the box, factory default pfSense. pfSense is going to, on the LAN subnet, its IP address of pfSense is 192.168.1.1 out of the box. So it's going to serve DHCP on that 1.0/24 subnet. And the default range is .100 to .199. And it's going to give out the client firewall LAN IP, it's going to give the firewall LAN IP address to clients as the gateway to use so that they will send traffic out through the firewall. And it's going to give them the firewall's LAN IP address as a DNS server because the DNS resolver is enabled by default. Now, all of that can be controlled in different ways, and I'll go over all the options here in a minute. But it's very important just to keep this in mind if you're rolling out a new firewall. If you're hooking it up in a lab, or if you're hooking it up to an existing network, keep this in mind that it's going to be sending out DHCP on the LAN, and it's using that subnet. So if you have a network that's already 192.168.1, and you're trying to hook up a fresh pfSense to it, if you hook the pfSense WAN into that 192.168.1 network and the LAN side is 192.168.1, it's going to blow up. So you don't want to do that. So you'd want to renumber your LAN side first, or disable DHCP, or actually you'd have to renumber LAN in that scenario. But you may end up in a scenario in the future where you may have to disable DHCP before you plug the LAN side into something as well, so you don't have conflicting things. But default out of the box behavior, that's what it does. All right, so the address assignment behavior, this is what happens with the DHCP daemon, and as somebody just asked in the chat, asking what the daemon is, it's the ISC DHCP daemon, so ISC DHCPD. And this behavior is taken from how it's described in their manual page, just shortened a little bit, massaged a little bit. What happens is, brand new client comes onto the network, it sends out a discover request. And the server will check all of its records. It will check their static mappings. If it finds a static mapping, it will use that. If there's no static mapping, it will check for an old lease that's still valid. If there's an old lease, it'll offer that. If there's no old lease, it will check for an IP address the client might have had before. If it's still available, it could offer that. If the client can't use it, then it'll free up that old lease. Then it will check all of the pools for the network clients in. It will check the permissions, like the MAC address controls, or if you've denied unknown clients, and if it's a known client or not. It will try to locate an available address in the pool. If there's one that's available, just free and open, it'll offer that. If there's not, it will go through all the addresses, look for one that is expired or not currently in use, and it will try to reassign that. It will send a ping to that address and try and make sure it's open, and if it is, if it doesn't respond, and so it determines it's open, it will reassign that lease to this new client. And so if you have an existing client, like one that was an offline overnight, whatever, it might send a request for the address that it had previously. And the server can do three different things there. It can either allow it if the address is available. If it's not in use, if that address is in the pool, it meets all the other criteria. If it's allowed to have it, then it may just allow that. It could deny the request if the address isn't available, or it can't access it. It's not the right network. It's something that's not a static mapping that it matches, something to that effect. Then it'll deny it. Or the third option is to completely ignore it. If the address is not one that DHCP knows about at all, it may just choose to ignore that request entirely. And then the client would back off and send some other kind of request on its own. That behavior is up to the client, though. So there is no set pattern to the pool assignment out of that it uses. It generally tends to be in ascending order, but it's not guaranteed to be in ascending order. So you might notice that it does, it starts, if your pool starts at 100, it might assign 100 first. It might assign 101, then 102, but there's no guarantee of that behavior. That's just generally how it behaves. But there's no way to influence that. It's just decided by the server, not quite at random, but it has its own algorithm internally to determine that. And for all of these things, it does send a request to make sure that an address is free before we'll allocate it to a client. So if it decides to use an IP address, it'll send a ping to that address, waits for a response just 1 second, and if it's free, it will assign that to the client. All right, we'll talk a little bit about the DHCP server configuration. We'll go over all the options here, but we may make a little bit of a detour when we get to a couple of the options, because just the way things flow logically, it tends to be a little bit easier to talk about in a little bit different order. First up, this is under Services in DHCP Server is where the options are. And you will see one tab here for every static IP interface you've got. So if you have a static, like a static IP address on your WAN, you'll see a WAN tab here, but you wouldn't want to enable DHCP on your WAN. Like if you're LAN, DMZ, phones, whatever, each of those is going to show on their own tab. When you check enable, that will enable the DHCP server for the LAN interface, which pretty basic option there. If you do have it enabled, it does have to have a valid configuration. So it will enforce some values there. You have the deny unknown clients box here, which if you have that checked, the clients have to be set in a way that they're known to the server. So what that is, it's basically just a static mapping entry that has at least a MAC address defined so that it's listed as a client. And I'll talk about that a little more when I get to static mappings. Basically just defines a record that says, I know you. Then underneath that you have ignore denied clients, which rather than sending them a rejection, will ignore them, which controls that behavior I talked about a moment ago a little bit. But that option does not work with failover. So if you have a high availability setup, you're not going to be able to check that option if you have the failover peer addresses configured. All right, underneath that, we've got our range, and above the range, you'll see that shows you the subnet and your subnet mask and the available range of hosts inside that subnet. So now that doesn't take into account things like the firewall itself or any other routers or static addresses, static mappings, virtual IPs, anything in there. It's just a general guide to say, okay, well, here's your range inside the subnet, and the range has to be within that. So you just need to fill in your starting address and ending address, like here I've got from 100 to 202. And again, that's inclusive, so a client could get 100, a client could get 202, or it could get any address in between, as long as it's available and permitted for that client to have an address there. I'm going to skip down a little bit and talk about MAC address controls, because that will give us a little foundation to talk about the additional pools. We have MAC address controls down here, and they allow you to put in either a full or a partial MAC address to control if clients can be given addresses from this pool. There's two options, allow and deny. If you have a MAC address listed in the allow field, then only those MAC addresses will be allowed to pull addresses from this pool. So if you have allow filled in, you won't need deny because everybody else is denied. If there's also the MAC deny box, so if you put those MAC addresses in deny, or partial MAC addresses, then they will not be able to pull addresses from this pool. They'll have to pull from somewhere else, or nothing at all. So if you have deny filled in, allowing everybody else is implied. So if you have deny filled in, you don't need allow. You'd never want both, because if you have allow, there's an implied deny of everybody else. So you really don't want to have both. So what this allows you to do is control who gets addresses from where. So when we have these additional pools, what they allow you to do is, okay, these clients here, which I've got 3 partial MAC addresses, which are just prefixes, and generally your OEM prefixes are going to be, 3 portions of the MAC address, 3 bytes of it. And sometimes you have to find those by trial and error. You might be able to find a list. Usually if you have a batch of things like phones from a given vendor, they're all going to be generally under the same prefix. So right here I've got 3 different MAC addresses, and these are just 3 MAC prefixes of some Apple devices that I had around the house. Now we have these pools that we're going to work with, and there's several ways you can use these pools. You can use them as extra space with no restrictions. So it could just be, a second segment of your network that you need to add. Say you had some statics that you put right after your first pool, and you need another pool range, but you want to after those statics. Or if you need to carve up your current pool into two smaller pools with some statics in the middle, you could do that. Or like I'm showing here, you can use it to direct some clients into a second pool, whether you're doing it by MAC address, or you could have known clients come out of your main pool, unknown clients out of the second pool, things of that nature. Or even like I had another example here of game consoles. We've had some people where they wanted to put game consoles into a small pool, and then they had a different like static NAT for game consoles out of that other pool. Which was a little bit different scenario. But so there's several different things, several different use cases, and there's a lot more that I'm thinking of, especially like phones, like I mentioned, where you may have phones that need an alternate gateway to go out a second VoIP network, or they may need two different vendors of phones may need two different types of TFTP settings or something like that. So those are things you need to watch out for that are common uses of these fields that will be enabled by using these options. So when you're working with these, you just need to come down here to the pools, and you can click plus to add a new pool. I've already got one here, so I'll just edit this pool. And really all you need to do is you can give it a pool description. You could do deny clients or ignore clients if you want here. Give it a new range. It just can't overlap any of your other DHCP ranges that you've got in use. And you have all the same options here that you have, or not all of the same, but a good chunk of the same options as you do in the main thing, or in the main options here. So your MAC allow and deny are what I'm using here in this example. And you can see I denied these MAC addresses out of the first pool, and I've allowed them here. So what that means is these devices and only these devices are going to be able to pull addresses out of this pool. Nobody else can, but they will be rejected from the first pool. So you could even have it like a different variation of that, where some people can pull clients from everywhere, but then maybe you have no restrictions on one pool and then allow them out of here. So there's a bunch of different things you can come up with to change these two. But just in this quick little example, I just use these three prefixes just to show you that, I've nudged these clients into the separate pool. So, once you've got this, you can put in your controls. You can, deny the unknowns if you want to out of this pool as well. You can generally just set up any other custom options you want if they need different DHCP or gateways, things like that. You can set all those. And then once you've got that, it's all good. Then, as I said, in my setup here, this first pool will be for everybody except these Apple devices. And then my second pool is only for those Apple devices. And you can use that same logic, like I said, for phones or consoles or whatever else you want. And you can find those MAC prefixes by looking at the leases. And as you can see here, I've got the Nmap installed, so it's showing me the vendors for the MAC addresses here. So I just found the leases here and took the prefixes and then dumped them in that dumped them in there in that MAC address, allow and deny, and comma separated values. So not hard at all to do that. Now, if you were trying to cover a wide range of Mac OEMs that you don't know, you might have to look at there is I think an IEEE list of Mac OEMs or OUIs, I think is what it used to be. Nmap maintains a list, several vendors maintain a list. You might have to comb through that and find a bunch of different prefixes for different manufacturers. All right, well, we'll look down here a little bit more. Next up is the server section, which is for DNS and for WINS. For the DNS servers, there is some logic behind how this works. By default, those options are blank. And when you can change that behavior in a couple different ways. Clients will get assigned DNS servers by the firewall, if you have your DNS forwarder or resolver enabled, it'll behave one way. But if you have values filled in here on the DHCP server settings, those are always going to be used. If you leave those blank, then that's where the automatic behavior kicks in. If they're blank and you have the resolver or forwarder enabled, then the IP address of the firewall is going to be given to clients. If you don't have the resolver or forwarder enabled, then it will try to hand out the DNS servers you have defined under system and general setup. And if none of those are filled in either, then it will not hand out DHCP or DNS servers by DHCP. Similar to DNS is WINS. You're not going to see WINS a lot these days. It was for older Windows networks. It is used as an alternative to NetBIOS for locating and browsing things on the network. But if you still happen to have something there, you can pass out those WINS servers. But more often than not, those are left blank, or some people might point them to an Active Directory server, but they don't do a whole lot these days. But if you've got WINS, you'd know it. All right, these other options as we go on down the road here, we have a gateway option. The gateway is generally left blank, so the firewall will hand out its own IP address. The only time you'd want to fill in an alternate gateway there is if the firewall is not the default. If you have some other router on your network that you want to hand out, then you put it there. Or in a high availability setup, you would put a CARP VIP in there so that the gateway is set to that. And it's similar for your DNS servers up above. If you had HA, you'd put in your CARP VIP for your DNS server. You want to put that in manually. But if you're interested in the HA stuff, there's a whole hangout on a couple of hangouts we've done on high availability that you can refer back to. You also have a domain name field you can fill in here. Now this is a domain name given to clients, and they'll use it as their DNS suffix. They'll use it for short name lookups just out of that domain, but it is not used by the resolver or forwarder integration. So if you're in DNS resolver or DNS forwarder and you have that integration turned on, it doesn't pull this domain name in here. So this is generally just for use by the clients. It's not going to be used by pfSense itself. Underneath that, we've got our domain search list here. The domain search list is a little misleading, but nothing that's our doing here, because you can give a list of domains to a client so they can use a lot of short name lookups on multiple domains, but that option doesn't work on Windows clients. Windows clients just plain don't request 119, that DHCP option 119. They don't respect it, but it will work on Linux and OS 10 and other operating systems that support it. So that's something, a lot of people might see that and think, oh, hey, I can use that. And then, hey, it doesn't work. Well, if it doesn't work, it's because your client probably doesn't support it. All right, talk a little bit about the lease times we've got next in the line here. The default lease time is going to be the lease time that it gives to clients that just don't ask for a specific time, which is pretty common. So as we see here, the default lease time is 7,200 seconds. And then the maximum lease time is, if a client asks for a specific time, it will allow up to this amount of time. So a client could request a week-long lease, but no, we're not going to allow that. We're only going to allow, by default, 86,400 seconds, which is 1 day. So I think you can't have these set identical, but they can be close. If I remember right, I can't remember if there was a use case for setting those similar, but you really, some people do want them close together for some reasons, but generally the max is going to be a little bit longer than the default time. Now, in the case of both the default lease and max lease time, you want to make sure it is equal to or greater than a captive portal hard timeout if you've got captive portal active. The reason for that is if you have a lease time that is shorter than your captive portal timeout, and a very, very busy network with a lot of client churn, that IP address could be reassigned and reused before the captive portal times out, which will mess up the captive portal session because the MAC address will have changed for that IP address, and it will, get confused. It might kick out the session. They may, their login behavior may not work quite like they want, because it'll think somebody's trying to hijack that session. So by keeping your lease time longer than your portal timeout, then you're pretty much guaranteed that the portal is going to time out before the lease, so that the next time somebody gets that IP address, it will be a fresh captive portal session. Underneath the max lease time, we've got the failover peer IP address, which You're going to leave that blank on everything except for a high availability setup with CARP. When you have that set up, you're going to put in the IP address of the opposing node, and then when it synchronizes, the other side will fix itself to be to point back here. Again, if you need the details on that, you can refer back to the HA Hangouts we've done before or the book. All right, talk a little bit about static ARP, what it is and isn't here. We have a static ARP option here, which you can see right there. If you have that box checked, and this option works whether or not you have DHCP enabled on the interface, because the static ARP options mesh very nicely with the DHCP options, so we have them in the same place. But you might want static ARP without DHCP. So the static ARP option here and in the static mappings, they will work irrespective of whether or not the server is enabled. So what static ARP does is it disables dynamic ARP requests. So when you have static ARP enabled, the firewall is only going to talk to other systems on your local network that you have defined by IP address and MAC address in static mappings. Because normally the firewall doesn't know about everybody on your network. If somebody tries to talk to the firewall, or the firewall wants to talk to somebody on the local network, it's going to send out an ARP request saying, okay, who's got this address? And then that other system will respond back and says, oh, I've got it, and here's my MAC address, and then they'll talk to each other at layer 2, which is a great thing for ease, for convenience and ease of talking to clients and things. But there are some security implications there. You could have IP conflicts for two different MAC addresses trying to use the same IP address. You could have somebody doing that on accident, or somebody doing that on purpose, trying to stomp on somebody else's connection. You could have a case where you only have a set number of clients, and you don't want to allow anybody but your known clients to talk to you, to keep out any other additional clients that could be either unknown or malicious. Somebody jacking into a switch port that you don't want, or whatever. So what you do is you make those static ARP entries by making these mappings. So you have a known record of IP addresses and MAC addresses in pairs that you want to talk to. So when you do that, it sets up all those in the ARP table as permanent entries, and it disables dynamic ARP on the interface, which is very, very secure, but it is a pain in the rear to manage. So each pairing has to be added to the firewall and maintained. So every client you add has to be tracked. Every client you take away has to be tracked, or should be tracked. If you change out a network card in an interface on a computer, say something gets fried or somebody gets a new computer, you're going to have to update this list of static mappings. So it is very secure, but very low on the convenience angle. But some people insist on it because of their particular organization's security policies, and it can be beneficial. But these days there are a lot of nice layer 2 port security options on switches, which are probably going to be a better compromise for most situations. Things like shutting off other ports, limiting ports to just a MAC address, not allowing changes on ports, things like that. So, or private VLANs, or where you have like one designated gateway port and you have your private ports, and they can't talk to each other. Or there are lots of layer 2 security things that you could. That's a whole separate hangout on switches that we'll probably never do because it's not pfSense. But that is very easy to do. And as for things like MAC spoofing, yeah, sure, you could spoof MACs if you know the MAC address and the IP address pairing that you want to spoof. You could do that. However, if all of your hosts in your network have dynamic ARP disabled, and you are on a switch, and unless you've already got access to the switch's CAN table or whatever, or the firewall, you probably aren't going to be able to know or find that MAC address unless you have physical access and look at it on the NIC, or if you have access to the machine, you strip it off there, and you could do that. But if you have your switches set up right, that may not matter, because of whatever port they're on the switch is going to be locked down, not the firewall. So there's a better case to be made for handling all of that layer 2 security on your switch, not on the firewall. Which, or a combination of the two. So if you're worried about that, you can do it this way. But when it comes right down to it, if you're looking to secure ARP and things like that of that nature at layer 2, you probably need to be focusing more on your layer 2 security. And another thing is, you can, instead of doing static ARP entirely, the mappings have an individual option where you can set like a one-off static ARP entry for one system instead of setting it for everybody, which I'll talk about that when I get to static mappings. But if anybody's knowledgeable, they can know how to spoof a MAC address, but they have to know which MAC address to spoof, and that knowledge may be a little harder to obtain. So, it's not as easy as it was back in the day when you had a hub and everybody was seeing everybody's traffic, and so it's there's a lot between switches and other things. There's a lot more security there than it used to be, but it still is a pretty hairy topic. So, all right. So moving on to other things. The option right under there, under static ARP, is for time format change. And what that does is it change, by default, the ISC DHCP daemon will track the lease times in UTC or GMT time, or UTC is what it is, so universal time. And so that's not most people's local time. So looking at the leases, logically doing your in your head time conversion is not most people's forte. So you probably don't want to be doing that. If you want to think of these leases logically in your local time, check this box, and then on the leases page, when it puts out the times, it will put them out in a nice display of your local time instead. Underneath that, we've got a statistics graph option here to enable an RRD statistics graph. And when you have that set, if you go to status monitoring, it's going to show you a pool usage graph for the main pool. It doesn't support multiple pools, but I'll talk about that graph later on. All right. Next, we have all these sections that are advanced options, and they're all hidden because most of the time most people don't need them. But if you want to get to the options in each of these sections, you just click Display Advanced. And if there's settings in them, they'll display automatically. Like if I refresh this page, I've got MAC addresses filled in, so it will show these MAC address controls automatically. So first up, we have Dynamic DNS. And these Dynamic DNS options are for registering your client host names in an upstream DNS server. So if you've got a DNS server that supports registration, you can set up a zone on there and make zone update keys, things like that. Setting up the server part of that is way out of scope for us here, but the settings you put in here is you put in the domain name that they're going to register under. You put in the IP address of the DNS server where the updates will be sent. And then you put in the domain key, which is the name of the name of the domain key, which is usually just the same as your domain name, but that could vary. And then you have your secret key, which is like the password. It's an HMAC MD5, hashed version of the key. So that update key will be sent to the server along with the other information, sort of like the RFC 2136 dynamic DNS updates. And so that will let the DNS server handle the DNS registration to another server. As long as you're talking to a server that's compatible with that protocol, it'll let you keep those up to date. All right, skipping down, since we already talked about MAC address controls, next up we have these three little sections here: NTP, TFTP, and LDAP. NTP servers are just time servers you want to send out to clients. Whether or not a client supports that depends on the client. Next is the TFTP server, which is used generally by VoIP handsets and things like that. The behavior and what you need to put in there varies by client and obviously your providers and PBX vendor, things like that. That's also known as option 66. So if you see somebody talking about option 66 for a phone, you can put that here in the TFTP server. You don't have to go fiddling with the numbered options. Underneath that, we have an LDAP server, which is for uniform resource locator, located for an LDAP. So it would be like your whole LDAP URL to your LDAP server with some of the schema afterwards. That is commonly used by OS 10 or Mac OS for the Mac server network type things, possibly for others. That's also known as option 95. So if you're in a Mac oriented network, you may have to fill that in to help clients locate where to sign in by default. Underneath those, we have our network booting option, which is a little beefier. Now, network booting is just like PXE booting or PXE booting. So you'd have the enable toggle that toggles whether or not any of the options are actually sent. So you can define them without sending as long if you don't have it enabled. Next server is the IP address of the server that contains the boot files. Your BIOS file name is the boot file for older style booting, or just what, on older systems, what's just going to be your default booting boot file. And then we also have fields for UEFI for 32 and 64-bit file names for more current systems that support UEFI. And then there's a root path, which you can give to a storage path for. Again, that's all, that's all between what your server has and what your clients expect and things like that. So generally, you'll know what to put in those based off what you've got. Alrighty. Now, beyond the options we have in our GUI, you do have the capability of using DHCP options that are numbered. Any numbered option you can think of. There's some lists here that are available that I've got linked that you can look over. But there's a lot more options out there than we could ever put in the GUI. And some of them vary a lot on client support. And so when you put these in, every one of them is going to have an option, a type, and a value. So your option is your number. So for these examples down here, like option 26 is MTU. You put option 26, for example, and then for the type, you'd put like it's an unsigned 16-bit integer. So, and what you want to figure out for these, if you need to know what the types are that go with each option, you can refer to those links. Each of those links has a listing for what types and how long they are for what these take. Now, there's a slight difference between text and string. Text is like a hex representation of a string, and string is actually a string. And there's tons of, like somebody else just mentioned, option 252 for WPAD for putting out a squid URL. But there's also like 121 is a classless route, and that's usually a text option in hex where you have like you have a network, a subnet mask, and a router all packed into a hex string, but converting into that is beyond our scope. But the options are there if you have to do that. So using this is very powerful, but it's also very rarely needed. And if options are very commonly used here, eventually we may grow them into a GUI option. But that's what happened a lot. I mean, we used to not have things for like LDAP or TFTP and things we've built into the GUI over time. So those are handy, but you may not ever need them. But there are a lot of use cases for those. All right, moving on down is we have our static mappings. And you can either click plus to add a static mapping, or I've already had one here, so I'm just going to edit it. And what these static mappings allow you to do is several different things. The most common use, of course, is to map a static IP address to a specific MAC address. So you fill in the IP address in the MAC, and if that MAC address requests a DHCP lease, it's going to hand it that IP address. So it gives it that mapping when it's asked for it. Or even if it asks for no IP address at all, that's the IP address that's going to hand it. If it asks for something else, because I know you need to use this one instead. It's also a shortcut for creating a static ARP entry. If you fill in you could fill in the IP address and MAC to get the static ARP entry. And then if you set the option here on the static mapping to do a static ARP, it will put a static ARP entry in all the time, or any of these that you have filled in. You don't have to check that box to do a static mapping here. You just need to have it set on the main server, and then it will read all of these and use them. Or you can also use this for the deny unknown clients feature by just putting in a MAC address and a host name. I think it also requires you to fill in. It's not necessarily required that it matches anything for the host name. It really just needs the MAC address to list that as a known host. Something that trips a lot of people up is these static mappings cannot exist inside of your ranges or pools. The reason for that is because the ISC DHCP daemon does not support a reservation as, you get this IP address and nobody else can ever use it. That's not how they work. They are a preference for an address. So if they were inside your pool, then somebody else, if they needed an IP address, say your pool was full, somebody else could use that if your static client was offline. And then the static client comes online, there's no address there for it to use, and it might get something else that may get nothing if the pool's full. So because of that very confusing behavior, we have opted to restrict them so where they're outside of your pool, so you don't get bit by that unexpected behavior. So, if you need a static mapping, it's got to be outside. It could be before, it could be after. You could have multiple pools. It could be in the middle, between two other pools. They just can't be inside of your pool ranges. And another restriction is you can't have the same MAC address or IP address twice because you could have ambiguous or undefined behavior. We've seen people request where, hey, I've got two different MAC addresses I want to associate with one machine because it's got wired and it's got wireless, and it wouldn't ever be on the same two at once. And but there's a chance they could be both active at once. And if that were to happen, the behavior would not be predictable. So we've opted, at least for the moment, we may back off on that later, to where you can't have them defined twice. And obviously you can't have two MAC addresses for the same IP address, for similar reasons. All right, so looking at the fields on this page, we've got our MAC address, obviously, which is the MAC address of the host, which you can find in various ways. That varies from client to client. And finding the MAC address is usually pretty easy. But if you're accessing the firewall from the host you want to do a static mapping for, you can click this Copy My MAC button. It'll copy the MAC address of the host you're managing it from, and put it there in the field, which generally that you're not going to do that a lot, but it could be maybe you want to give your own administrative workstation a static address, and that's a convenience feature for that. But it does need to be in this format here, where it's in 6 segments separated by colons. Different vendors have different representations. You might see it as 2 portions with a dot between it, or you might see it with dashes in between the symbols. You might just see it all run together. But this particular case, we need it in colon separated format. So, 6 hex octets separated by colons. Underneath there is a client identifier, which is usually left blank. It's an additional matching parameter. So if you need a client a client would have to specify this identifier in the client settings before it sent that. Generally not going to see that used a lot, but if you need an extra matching criteria, you can. So if you had the MAC address and the client ID filled in, it would have to match both of those before it was able to obtain this IP address. And underneath there we have the IP address, which if you put in that IP address, it will create a static mapping. If you're doing static ARP, you need to have the IP address and the MAC address filled in. If you leave that IP address blank, it will just assign an address from the pool, but it considers it a known client. So that can keys back to the deny unknown clients option. All right, we've also got host name, which is just the host name portion, not the fully qualified domain. So just the host name portion assigns to the client. Usually a client will actually take that and use it. That host name is also shown in the lease status and elsewhere as the client's host name. It will be, if you have the DNS resolver or forwarder integration on, it'll use that host name for resolution there as well. And then you've got a description, which is a free form, just a reference for what this host is. So you've got the static ARP entry here, which I've mentioned a couple of times. If you have that set, it will make a static ARP entry for that mapping, even if the DHCP server is disabled. So again, that operates independently of the DHCP server settings. If you have that filled in, or if you have that option checked, you have to have a MAC address and an IP address set. And a static ARP mapping on its own, without the whole interface being set for static ARP, it will prevent other MACs from clobbering that IP address, so it will lock that IP address to that MAC, but it does not limit that MAC address from using other IP addresses. So if somebody is hard coding something on a server or client, that system on that network card could use several IP addresses or some different IP address. The only thing this enforces is that when it talks to this particular IP address. It has to be addressing that traffic to this particular MAC. And then all the other options here you see are going to be the same as your DNS server options that we've already gone over. They're just specifically handed out to this client. If they're left blank, it falls through and use the options from the main pool. Same thing with the additional pool options. You leave something blank, it'll fall through and just use whatever the options of the main pool are. And if you have something in here, it will override the others. So not all the options are possible, like your numbered options aren't here. And that's just a limitation of the screen at the moment. That may grow over time. But, you know, so you can override most things, but not everything. All right, going over the lease status here, which I kind of looked at earlier. This whole layout here, it's under status and DHCP leases. And we have, you know, columns here for the IP address, the MAC address, your host name, your description if it's a static mapping, the lease start and end times, which are filled in, but they're, you know, if it's a static lease, it's not going to show you anything. The online and offline status keys off of whether or not the system has talked to the firewall recently, basically if it's in the ARP table. The lease status could be active or static or expired, depending on what you've got here. This is a sortable table, so you can sort these by IP address, and if I sort it by IP, you'll see I've got this address up here. The static mapping is at .10, and it's way outside my range. And then I've got some clients here that are inside the main pool. And then my Apple devices here that I had restricted, you can tell that they've pulled addresses from my second pool. And down here at the bottom, it does give you a count of the leases that are in use for each pool. If there's a pool that's missing, it means there's no leases used in that pool at all. But so you can see right now I've got 5 clients in my main pool, 3 clients in my my Apple pool. And there's also controls out here at the end of each row. You can add a static mapping, you can add a wake on LAN mapping or you can send a wake on LAN packet if it's offline. Or if it's offline, you can also delete the lease out of the lease database. You can't delete an active lease. You can't send a wake on LAN packet to something that it thinks is active. So it's pretty self-explanatory there. And you can click the Show All Configured Leases button down here to show the expired leases as well, or leases that are in the database but are not currently active. Like you can see some of these old leases from the other pool for those Apple devices. Now an expired lease is going to show if it's been superseded by some other lease or if it's outside of the valid time. You can see there if it's active, it's within your configured lease time and the clients, you know, has requested it recently, and so it's inside that lease lifetime. One other thing to notice about that offline-online status, that is keyed off the ARP table, so something could be online, something could actually be live, but not show there just because it hasn't talked to the firewall in 20 minutes. So in order for it to show up as online, it has to be talking to or through the firewall, so that the firewall will have seen its MAC address in the ARP table. Also, if you've got static ARP, it's probably always going to show online, since that's how it keys off that list. Something else you might see, if you have high availability, you'll see a pool status here for failover. Every pool will have a failover configured. So every pool is going to have a different row here. This is a different pairing of systems here I've got for that have HA going. And in those 2 systems, they both show a normal status. If something is wrong, it might show, you know, communications interrupted or something. And so with HA, you're gonna see a list of failover pools, or at least one for your LAN, if that's all you've got. And then it'll have your leases down here below. And lastly, we have our pool usage graph, which you enable if you enable it under the main DHCP server settings. If we come over here to status and monitoring, in the left axis or right axis, you can pick DHCP, and then you'll have your list of interfaces over here. And then click Update, and it will show you your pool usage. So right here, you can see, you know, for a while there was only there were 2 leases with 1 static, and now here there's 1 static and 5 leases, and there's 103 addresses in the range. Now again, at the moment, this only works with the main pool, not sub pools. So or additional pools. So it's handy within its limitations. And I think, yep, that's it. So that's all I was going to go over today. If anybody has any questions, you can go ahead and type them out now, or you might type a short sentence or something. Let me know you've got a question coming, because I know if you have a long question, it might take a while to type. But I've got a few minutes. We can go over anything else you want to. If there's something else you wanted to see that we didn't cover, if you have any questions about what we did cover, just let me know. Okay, Tyler says, what is the behavior if DHCP pool is exhausted and a client does a DHCP request? I covered that a little bit ago. Basically, it goes through the pool and looks for any lease that is not active. And if it finds a lease that's inactive in some way, whether it's expired or it's out, well, outside of its lease lifetime or otherwise, unavailable, it's going to test that address with ping to see if it's available, and it will reassign it. But if the pool is completely full, then the client is just not going to get an address. But it will try to locate an address, and it will reuse addresses if there are any that it's possible to reuse. Let's see. Does the high availability broadcast go over DHCP HA? Immediate question is what kind of HA is supported out of the box. Yeah, in the CARP or high availability ones with CARP, we go over setting up the DHCP server. Really, all you do is you put the CARP VIP on the interface, make sure that's all syncing right. You set the failover peer address in the settings, and you set your gateway to your CARP VIP. You set your DNS server to your CARP VIP, and that's really it. There's not much more to it than that. And then the settings for that will synchronize to the secondary if you have a sync set up, and then they'll come online and do that. When you do have HA and you have the DHCP server going in HA, they both run at the same time. So you have both DHCP servers active, but they decide internally, basically they split the pool in two. One's going to serve from the bottom half of the pool, one's going to serve from the top half of the pool, and they share lease information back and forth. So it is normal to see both of them active, and some leases in one, some leases in the other, which can be a little tricky to get used to, but it's normal. Let's see, is there a way to introduce a delay in handing out IP addresses? No, there's not a way to have any kind of a delay like that. I don't know if the daemon might be capable of it. I'm not sure, but we don't have any way to act in that capacity. For something like that, I'm not sure what you'd end up having to do. Probably some sort of high availability thing like that, but I don't know if I definitely don't think it could be a backup for Active Directory DHCP. But if you had two pfSense servers, you could probably do failover between those, but they would have to be on the same layer too. But if you're talking about doing something over a VPN tunnel or whatever, we can't do DHCP in that capacity anyhow. But if you might be able to do it between two DCs, but it's nothing we can handle at the moment. Now, something I didn't touch on though is another thing is DHCP Relay, which basically just relays a request for DHCP off to something else like IP helper on a switch. And that's, that also is something you might be able to look at, but that does not generally work doing it on the firewall across IPsec. But you might be able to work that out with your switches. Is it possible to configure the authoritative status of the DHCP server? No, if it's on, it's always going to be authoritative. There's not a way to change any of that at the moment in our GUI. All right, anybody else? Any more questions? Going once? Well, let's see. Well, was trying to think if there's anything else I didn't really look at, but just a reminder, if you want the manufacturers of the MAC addresses to show up there on the DHCP lease output, that is provided by the Nmap package. So if you put the Nmap package on just under available packages, you can search for Nmap, but you'll see I've got it here installed once it decides to talk to the package servers. Yeah, that's just from the Nmap package here. Okay, Marcus said you got a question about the SG-1000. I may or may not be able to answer it. I don't have all the info on hand, but if it's something I know off the top of my head, I can try to answer it. What you got? Let's see, ask about how the number of clients it can handle for basic stuff, nothing complicated. A fair number of clients. I mean, I think it has, I want to, let me pull up the specs on it if I can get it up here, hold on. Let's see. It has 512 mega RAM, so I mean, between the OS and everything else, it's probably going to be able to handle several 100,000 states. So, I mean, client capacity is not really going to be a huge problem. 20 would be nothing. I mean, 20 clients, even if they were torrenters, is probably still going to be under 50 or 100,000 states. So yeah. No, the SG-1000 is an ARM device, but it's not going to work on a Pi, as far as I'm aware, because it's a different processor and everything else like that. Because I mean, the ARM builds would have to be different. Plus, the Pi is awful for a firewall because then there's the NIC it does have is connected to USB, and it's just not very good. So the Pi is just bad for the role in general. The one we've got, it's got 2 gig ports, and they're actually connected straight to the system. They're not going to be things you have to worry about it being connected by USB. Okay, well, I think that's going to just about do it. I'm going to wrap up here, and thank everybody. Thank you all for attending, and we'll see you back here next month. Thank you very much.